Hi, this is Julie. This is the third video in this series about exponent rules, and in this video we're going to talk about the power rule for exponents. So again, let's look at a specific example of what we're talking about here, and then we'll write the general rule for the power rule for exponents. So let's say I have an example like this one here. I have 2 to the second power, and that entire exponent or exponential form of the number is also raised to a power. It's raised to the third power. If I think about what this means written out, it means that I'm going to have 2 to the second power raised to the third power. So I'm going to multiply it by itself again, 2 to the second power, and then I'm going to multiply that by 2 to the second power again, and so now I have 2 to the second power times 2 to the second power times 2 to the second power, which would be 2 to the second power to the third power. So if I break that down even further, I know that each 2 to the second power is 2 times 2. So what I really have here is 2 times 2 times 2 times 2 times 2 times 2. Or if I were to multiply that all back together, I can see that what I have is really 2 to the 6th power because I have 6 2's that I'm multiplying together. So if I'm going to go back and make a general rule, what I did is I took that original exponent on the 2 to the second power. Since that whole thing was raised to the third power, I multiplied those exponents together. 2 times 3 is 6, and that's the exponent I end up with at the end here. Now, of course, 2 to the 6th power is a number that I can figure out. I could multiply this out or input 2 to the 6th power in my calculator, and I could figure out that 2 to the 6th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power would be equal to 64. But again, the important part here that I'm worried about as far as the general rule is that 2 to the 6th power would be another way of writing that exponential form. So if I'm going to go back up here and write a general rule for multiplying or raising the power x to the m to the n power, again, the base will stay the same. My base is x. I'm going to take those exponents and multiply them together. So I will have m times n as my new exponent. So let's look at another specific example here. This time I have s to the third to the fourth power. So the entire quantity s to the third raised to the fourth power. And again, if I think about what that's really equal to, what I'm really saying is that I'm taking s to the third times s to the third times s to the third. My pen's not working very well here. Okay. And s to the third times, oh, sorry, I need one more s to the third in there, don't I? I'll get rid of that equal sign, and we'll go back over here, and we'll add one more s to the third in there. Okay, so s to the third times s to the third times s to the third times s to the third would be s to the third to the fourth. If I look at how many total s's I have all multiplied together here, I have 3, 6, 9, 12. So this would be s to the 12th, and that makes sense because I said the general rule is that I should multiply together those exponents, the 3 and the 4 here, to get my final exponential form. Let's look at one last example. This time, instead of multiplying it all or writing it all out, we'll just go ahead and compute it here. Base is q, that's going to stay the same. And this time I'm just going to go ahead and multiply my exponents. 4 times 6 is 24. It's kind of a big exponent, but that's okay. And so my final answer here would be q to the 24th power. So that's it. That's the power rule for exponents. In the next video, we'll take a look at another application of that rule.